So Euler's formula, probably one of the most important formulae in all of maths. Sometimes just for fun people put in theta equals pi and get the following. So when theta equals pi, cos theta is minus 1 and sine theta is 0, which you can also write as. So this equation has the 5 probably most important constants in maths: e, I, pi, 1 and 0. Anyway, where does Euler's formula actually come from? Well, one way to obtain it is simply from the Taylor expansion of e to the x. So e to the I theta is 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial plus I theta to the power 4 over 4 factorial plus etc. Then if we separate the real and imaginary parts, so for the real part we'll get 1 plus, and then we'll get a I squared is minus 1, so we get a minus theta squared over 2 factorial plus, we'll get a real part from this, I to the 4 is plus 1 plus etc. And then the imaginary part is going to be I times theta. I cubed is minus I, so just minus theta cubed over 3 factorial plus etc. And then hopefully you recognize this thing here is cos theta, and this thing in here is the Taylor expansion of sine theta. So if we have a number z equals r, we wrote z equals x plus iy, which you can also write as modulus r times cos theta plus I sine theta. Then we can also write that as r times e to the I theta. So the expression z equals r to the I theta is also extremely useful, and that's known as the polar form of a complex number.